So today I'm going to start a series talking about how I was able to image bootable floppies for my Model 4 using an IBM DOS machine. And I thought I'd start by talking you through the OS, which is where this all starts. So out on the web I was able to find images for DOS 622 install floppies and an image for a 1.44 meg floppy. I used an external USB floppy drive on my main work PC. It's a Windows 10 machine, and I used, don't remember, RawWrite or maybe WinImage. Used one of the programs you can find out there to read those raw images and write them to that external USB floppy drive, and that gave me a set of 3 floppies, which is the full install for DOS 622. And of course the first disk is bootable, so you use that to bring the system up and install DOS. On the machine I have a 1.44 meg floppy added as drive A. If I can get that to sit, I've got a 1.2 megabyte 5¼ inch drive that I'll be using to actually create the bootable floppies for the Model 4. As we move on to the computer, see if I can get this to swing around. This is a 486 motherboard. It's strapped for a 486DX33. It's got 64 megs of RAM in it, although that's really overkill for this application. I've got maybe a 2 gig, I don't remember anyhow. It's an IDE hard drive here that DOS was installed onto. I've got a very standard, it's actually an SVGA card, but we're using it in VGA mode. Since this is a pure DOS build, it basically relies on the 80 by 25 character mode, 80 column by 25 line character mode in DOS, which is a standard VGA video mode. So any VGA card will work for this. In this case, it's got a Tsing chipset on it. We're not doing Windows with this. You know, there's no Windows 98 or 95 in my build. It's purely DOS, and this card is more than adequate for doing the work. So let me get this card on the bus here. Sorry for reaching around the camera. A critical piece of this is the floppy controller, and this is the floppy controller I've ended up with. It's the WinBond chip. It's actually got 2 WinBond chips on it. This has got a floppy interface. It's got an IDE interface. It's got COM0 and COM1 parallel printer port, and it's actually got a joystick port on it as well. The jumpers on this are set to the normal default interrupts and DMA channels, etc. It's just all strapped as defaults. This card turned out to work well. The reason you potentially need an older floppy controller is it needs to be able to do double density. The Model 4 uses double density floppies. The 1.44 meg is a high density or a quad density format. I was unable to do this on a little bit later generation machine. I've got a Pentium 3 machine here, which the onboard floppy controller on that motherboard just wouldn't do 360K floppies. It's got a single ISA slot. I tried this card in, and again it was just not successful, which is why I've come all the way down to this just 486 machine. The other note on this 486 machine is I've got a Cyrix overclock processor in here. So this processor drops into a 486DX33 socket, and then it internally overclocks to 122 megahertz, I believe. This overclocked high enough I could actually run Windows 98 second edition on this machine, although for this demonstration I'm not going to do that. So let's get this guy hooked up and strapped in. And I need the IDE cable, which goes on here this direction. Got to make sure the red stripe is to pin 1, pin 2. That seems wrong. Red stripe, pin 1, pin 2. I had this jumper together earlier. Why does that seem wrong? Well, we'll find out. If it doesn't see the IDE drive, then I've managed to get the cable backwards. Anyhow, that's the core configuration of the machine. the next piece that's critical here is the BIOS on the machine you're using. So let's go ahead and see if I can reach around the camera here and get this machine started. We'll get a look at the monitor here. Actually, I want to get into the BIOS. And it's going to go ahead and boot. I've already got DOS 62 installed on here. But I want to go into the BIOS and make some key points here. As currently the floppy configurations are incorrect, and it's important that the floppy configurations be correct. So let me see if I can get into the BIOS. So there's the BIOS. In this case it's a graphical BIOS, which is why I have a mouse here. It's really important that the floppy drives match, the BIOS settings match the floppy drives on the machine. I actually had floppy A set to the wrong floppy. Anyhow, floppy A is now set to a 1.4 megabyte 3.5 inch, and floppy B understands that I have a 1.2 megabyte 5.25 inch drive out there. The key point being here that 1.22 or 1.2 megabyte, I'm pointing out actually here, this 1.2 megabyte floppy drive is capable of actually working in 360K mode. So it can do the high density along with the double density. And how this ends up being achieved in the emulation in this system is, and I hope you can see this, apologies for the fan noise, is I'm telling the BIOS this is actually a 1.2 megabyte floppy. And then when the system wants to talk to it in 360K mode, it'll do the appropriate things through the controller to get the drive in that mode. If I was to tell this thing straight it was a 360K floppy because I wanted to write 356K floppy disk, this setup would fail. These need to match the hardware you have. If you actually had a 360K 5.25 inch floppy drive on the system, you would want to set that to 360K. I have tried this with a 360K floppy as well, and it works just fine. But the BIOS settings must match the floppy drives you have assigned. Let me get out of the BIOS here, and we'll quickly boot the machine up. And I'll talk through a little bit of the decisions I've made on this. Now, I forgot to save the settings for floppy A. You can probably see it up there, and I need to go back and restart again and actually save the change I made for floppy A. Some of the younger people out there may be so used to BIOSes that just do all this stuff by themselves. They don't recognize that you've got to manage this yourselves. Oops, floppy A is a 1.44 megabyte, 3.5. And I need to save those changes. So on these older machines, if you're not familiar with it, you need to manage those BIOS configurations yourself, especially around DOS. So it's just access the floppy A and floppy B, and the machine will now boot. As I said before, this is a straight DOS machine. There's no Windows of any kind on it. The emulator I'm using to write these images is designed for DOS. You can run that emulator under Windows 95 or Windows 98. However, you must restart the machine in DOS mode. You can't run it in the command window under Windows. Again, a Windows 95 or 98 machine must be restarted in DOS mode. Anyhow, we're here. So earlier I did the boot from floppy, got the machine booted, ran the setup off the A floppy, built the partition, and installed the software. One more thing to point out here for people who aren't too familiar with BIOSes like this. You've gotten very used to modern stuff that's just very plug and play. Oh, that wasn't quick enough. I'm hitting delete here to get into the BIOS, and it's not always catching it. Something else that was important on this build is if we get into, I think it's an advanced, and your BIOS will be different, you'll need to dig through it. Is if I move down through here, you will see the system boot up sequence. I had to change this initially to AC, and what that says is when the system boots, look at the A drive first before you boot. Because my C drive was unformatted and unpartitioned, I set it this way so it would start the Windows 622 install from the floppy. And then that install took care of creating the partition and formatting and everything to install DOS on this drive. Now that it's been installed, I just go ahead and toggle it to C first, and that way the machine will boot automatically from the C drive, even if there's a floppy in the A drive. Again, this could be a trap for younger people who aren't familiar with how the BIOS works. Your BIOS, of course, is going to be different. These menus are going to be different. It may be all keyboard driven, maybe mouse, but these are pretty universal things. Something else I did in this, just so you see it, is I have enabled IDE LBA mode, and that's long block addressing, and what that does is allow me to have a partition on the C drive larger than 500 megabytes. If you're in F-disk and you can't create a partition greater than 500 megabytes, even though you've got a 2 gigabyte drive in the machine, you need to go into your BIOS and enable this LBA mode. The other thing I did was I just went ahead on this machine and did a, as you just saw here, let me say no, I did a detect master. And what that does is go out and talk to the hard drive that's on the machine and say, what's your configurations? Modern machines do this automatically. Older machines, you typically need to set this up yourself. In this case, it picked a user entry and put in the numbers the drive reported. On even older IDE drives, you might have to actually manually put these values in yourself. I could have a CD-ROM drive as a slave here. I haven't done that. You can find DOS drivers for CD-ROM drives. That might make it a little easier to move your content from your primary machine onto this machine. In this case, all of the DSK images and the emulator and everything easily fit on a 1.44 meg floppy, so I'm just shuffling content from my main machine over and on here via floppy. Anyhow, those are a couple of important points, and I hope that made some sense. So let me get back out of the BIOS. In this case, I don't want to save changes. And we'll let the machine come back around and finish booting. This long delay on the high mem test is because it's testing a whopping 64 megabytes of memory, and it's doing a full set of tests on those, and it takes a while. This is a case where, again, somebody unfamiliar with the older hardware could get hung up thinking the machine is locked or crashed. Just let it run. If there was 128 megs on this machine, it would take twice as long. But finally, boom, we're into DOS. So hopefully you'll be able to follow along here, that there's enough that you can see the screen well enough. So I'm using the M4 emulator. You can find it on TRS-80 or TRS-80 emulators.com. There's both a registered and unregistered version. I'm actually going to be running the registered version here. A thing to note is that the unregistered version can only process Model 4 floppies. If you try to mount a Model 3 floppy in it, it'll tell you it's unsupported. I went ahead and registered it because it appears the Model 4 Diagnostic floppies, or actually Model 3 floppies, and I guess there's a difference someplace in the disk that tells the system which they are. You can do all this with the unregistered version. It has some limitations, but for what we're going to do, those limitations beyond the Model 3 thing really don't matter. I've got a 1.44 meg floppy here. I've copied the emulator onto it, and I've copied 3 DSK images onto it that I want to create real floppies from. I'm going to go ahead and make a directory here, M4 registered. I'm going to go ahead and make that my default directory, and I'm going to copy all the content from the A floppy to here. And I always do this wrong. Do I need to do A:/? These little details, there it is. The registered version of the emulator also will let you do virtual hard drives in the emulation on the DOS machine, and that's what this HD format utility is. And there's a couple of utilities here to copy files in and out of DSK images, etc. But what we're really interested here in is the M4 exe, which is the emulator, and the 3 DSK files that are being copied to disk. or the 4. The utility.dsk file comes with the registered version, and it's got some utilities to deal with creating virtual hard drives. The last 3 DSK images, that TRS-80 I believe is the TRS-DOS bootable image. It's got the files on it to deal with the high-res card you can put in the Model 4. I have the card here. That's kind of how this all started. I want to play with that high-res card, do a set of videos on it, and couldn't get an image of the disk. And then I have 2 different M4 Diag DSK files there. I suspect they're the same, though I don't know that. Anyhow, the first time we run M4 here, it'll go out and benchmark your system, and it'll pick an emulation speed that'll hopefully be pretty close to what an actual Model 4 is. So it's doing that, and there it is. It tells me it's registered to me, and of course now you know my full name, although if you watch my blog, you've already seen it plenty of times. Let's go ahead and get off the splash screen. The first thing it tells us is there's no disks in emulated drive 0. And we're going to want to hit F8, as it says there, to get into this menu. So a couple of things you're going to see here. There are 4 virtual drives listed here. These virtual drives can have these DSK files mounted on them, or they can actually talk to real floppy drives on the system. So the way I'm going to create a floppy here is I'm going to press 0 to tell what I want to look at, or I want to mount something on the virtual drive 0. By hitting the tab key, I can get up here into this mode up here, and I'm going to go over to that TRS-DOS 4 high-res DSK, the one that I think has the high-res files I want to play with. And that mounts that guy there. And then I'm going to hit 1, and I'm going to type in here A colon. I want it to be capitalized just because it looks better. I don't think it's mandatory. And what that's saying is when you're running the emulator, the floppy 0 in TRS-DOS is going to that DSK file. That DSK file, of course, lives on the hard drive on the DOS machine. And then when we're talking to drive 1, we want it to go to the A floppy on the DOS machine. The point being, the A and B DOS floppies do not become automatically the A and B, or the 0 and 1 floppies here. You map it yourself. And I've actually done that incorrectly. This should be going to the B drive on the DOS machine, because the B drive is where I have the 5 1/4 inch. The B drive here is where I have the 5 1/4 inch drive that we can use to make 360K disks. So we've created those mappings. We've gone ahead and committed them by hitting the return key, and now R will boot the machine. And as you can see here, the emulator has just booted TRS-DOS from that 11 or that DSK file. This is TRS-DOS, so you need to pick a date that it'll take. 84 is a good year for that. And of course, that's not the actual date, but it's close enough. We now have that DSK file mounted, and it appears to be drive 0 to TRS-DOS, and it just went out and looked at that 1.2 megabyte 5 1/4 inch floppy drive and said there's no disk mounted. The light actually came on. The next thing I want to talk about here is media. I was lucky enough to buy a whole bunch of boxes of these Cow MD2D 5 1/4 inch floppy drives. MT2D relates to, these are double density, the 2D, and they're double-sided floppies. These are what you really need for your Model 4. They're getting a little spendy on eBay. Like I say, I was lucky enough to get a bunch of them really cheap. If you can, you should really be using 2D discs and not HD discs. HD discs refer to the high density 1.22 meg, or the 1.2 meg high density 5 1/4 inch. Boy, I said that poorly. Anyhow, if you can find 2D discs, that's going to work better for you. A couple of notes here. These are 40 track discs. It says 48 TPI. They're 40 track discs. 300 or 360K, so they are 40 track, double-sided, double density 2D discs. They're designed for that, and that's what the Model 4 is designed to use. You can take a 5 1/4 inch HD 1.2 megabyte disc and potentially make it work. I question how reliable it'll be, Those disks are formatted in 80 tracks rather than 40. The material used on the disk itself is different. They may work, they may not. Your mileage is going to vary. Use the real disks if you can. The second point here to make is that the reason I told the BIOS this drive was a 1.2 megabyte drive was that when the emulation talks to it in 360K mode, it knows how to put itself in the right mode, create the right magnetic fields, step the heads correctly to end up with a standard 40 track double density double-sided disk. So I should have some floppies here if I can find them. And there's one of the Cow MD2D double-sided discs, which is a pretty standard. These are actually nice discs. They've got the little white ring in here that makes the disc a little tougher. I'll go ahead and mount this disc in here. Of course, the top of the disc with the label, and this drive faces the lever. So the disc is mounted in the drive, and I'm just going to go ahead and format it as an initial test to make sure that I think the disc is good. So we're going to use drive 1 here. So it's the TRS-80 drive 1, and remember that in the configuration we set drive 1 to be the B:floppy on the machine. Don't need a name, don't need a password. I'm going to format it double density. Number of cylinders is 40. It's accessing the disk to see if there's anything already on it, and it's formatting it. A note here, I am very sure, although I haven't tried it, that this floppy controller cannot deal with single density disks. I believe double density is the smallest it can do. So if you're trying to do emulation like this for a Model 1, this configuration isn't going to work for you. Even if the Model 1 has a double density controller in it, the Model 1 requires track 0 on a bootable disk to be written in single density. And then the rest of the tracks are written in double density, and that's because of the way the ROMs in the Model 1 are written. It picks the single density controller to boot from floppy. So this is really a Model 3, Model 4 solution for getting actual bootable images. I'll let this go ahead and verify here. It'll take a bit, and we'll come back and we'll go ahead and get the backups onto the physical floppy and go from there. So the formatting is completed. Everything seems to be normal. I can now go ahead and look at drive 1, and it's accessing that 5 1/4 inch floppy drive, and it's a blank formatted floppy. I'm going to use the backup utility in TRS-80 to back up from drive 0 to drive 1. Well, it would help if I could type. And I want it to make it a bootable disk, move the system onto it. This is going to take that DSK image that we mounted as drive 0. So we can jump in here and look. This is going to take this DSK image that we've mounted as drive 0, and it's going to back it up onto TRS-80 drive 1, which is mapped to the B floppy, and that's how I'm going to create that bootable floppy. So let's go ahead and run that backup. It'll do a bit of poking at the disk, and it'll tell me that the ID is different, but that's fine. In this case, this isn't a problem. What it's basically saying is, hey, wait a minute, the DSK file is a single-sided image, and you have a double-sided disk. Are you good with that? And I am. That won't make a difference. And it's now reading from the DSK file and writing to the floppy. And I believe, I don't remember if backup, I think backup comes back and does a verify pass after, I don't remember. And let me see if I can get kind of both of these in shot. No, I really can't. You can see here the B floppy clicking away. I hope you can hear it. And we'll just go ahead and let this run. Oh, there it goes, verifying cylinders. So it looks like this backup utility reads enough cylinders to fill up available memory, writes them to the floppy, then verifies them, and then goes on to the next set of cylinders. So we'll just let this run. So the backup is completed, and we can go ahead and take a look at drive 1, and we should now see it's accessing the floppy. And we should see the same files on drive 1 that we see on drive 0. Excuse me. Which we do, and because we use the /sys in that backup command, the floppy drive we've just created should be bootable. So I'm going to go ahead and pull that floppy out and set it aside. And I'm going to move on to the next floppy image that I want to create. So I'm going to hit F8, and I'm going to change out the image for drive 0. And I'm going to change that by hitting the tab key again. I can come in here and I can grab this Model 4 Diag disk. And if things are working correctly, that should have worked. That's actually a Model 3 image, and in the unregistered version it would give me a warning it was a Model 3 image that it couldn't deal with. And then I'm going to go ahead and hit R, and that'll reboot the system from the floppy we just mounted. The disk in the drive is a Model 3 disk. Oh, this is right. I've got to have the Model 4 ROM file in the emulator directory. I read about this and forgot about it, so I'm going to have to find a Model 4 ROM image and get into the emulation directory. So I will read up on this and see what it takes to get that image. So I've read through the instructions, and I actually have a couple of questions here, and so I'm going to play around a bit. I'm going to go to drive 0, and I'm going to go ahead and mount that bootable image I had, and then I'm going to go to drive 1, and I'm going to mount the utility disk that came in the registered version, because I think that's where the file I need lives. And then I'm going to go ahead and reboot the machine, and I'm going to look at drive 1. No, that's not where the file I need is. Maybe it's on drive 0. No, it wouldn't be there either. To install the Model 4 emulator, virtual disk image of LDOS 631. I need a virtual disk image of LDOS 631 to extract a file off it. So what I've done here won't work. I'll go look for a virtual image of LDOS 631. So I was able to find some LDOS 631 DSK files. I've got them on the floppy here. And what I need to do is exit the emulator. I just hit F7. I need to hit Shift F7. And yes, I want to exit the emulator and get back to DOS mode. Now I'm back in MS-DOS. I'm going to put that floppy in drive A. I'm going to take a look at drive A. Gee, did that backwards, didn't I? And we should have 3 DSK files on here. And I'm going to go ahead and copy those into here. I believe the 2 I need are the LD631 L1A file and then the LDOS 631 DSK. There's 2 of them there. One's 193K, the other's 377. And I believe those are the 2 I need to do this. It looks like LDOS is on 2 floppies. So I believe one of those will probably have the files I need in it. So those should now be on the C drive of the DOS machine. I'm going to go ahead and start the emulator again. I'm going to hit F8. I want to mount a different image on drive 0, tab, and I'm going to take what I believe was the A disk image, and then for drive 2, actually drive 1 I mean, I'm going to take what I believe was the, well, I don't remember here now which one of these was which. I believe this appeared to be the disk B in the set. And then I'm going to go ahead and hit R to reboot the machine. And there's LS-DOS 1111. I'll just use 84 again. Don't care about the time. Directory of drive 0. And I'm looking for a file that I believe has the extension III on it. Oops. dir drive 1. Maybe it's on that image. And I don't see it there either. I'm going to go ahead and go back into F8, and I'm going to change the image on drive 1 to this DSK image and see if the file need. Oh, I did the wrong one. I want to go to, yep, fumbling around a bit here. Then for drive 1, I'm going to pick this image, and it won't mount it. So that's what I was afraid of. So these images don't have the file I need on them. That's sad. Expect to find on one of these an image that has a file on it, something like Model 3/III or something like that, that is a image of the Model 3 ROM. And I'm not seeing that on here, and that needs to be transferred onto the DOS machine. I'll just do one more look through these. And it's not here. Well, we're on a journey, not making progress at the moment. So we're back over at the DOS machine. I've done a whole bunch of digging trying to find the Model 3 ROM images I needed, and I'll be back in a second. Let me go grab the instructions. Anyhow, the Model 3 ROM images I need for the M4 emulator to actually run in Model 3 mode. The comments in this So, installation, if you have the registered version of the emulator and plan to use a Model 3, you should also create a Model 4 ROM and place it in this directory. There are two ways to create the Model 4 ROM. Okay, I'm reading through the instructions here. So, he had mentioned in here that if you had the virtual disk image LS-DOS 631, you would find that Model A/III ROM image in it. I've dug through a whole bunch of DSK files looking for that image and didn't find it, and did a bunch of digging on the web and came across a web page. And I searched on the web page for the Model A/III file, found it in a new DOS-80 distribution. There was actually 3 different disks with it on it. I think they're all the exact same file. Anyhow, I went ahead and extracted all 3 of those files and have them on a 1.44 meg floppy here. And I thought we'd give these a shot. So on my main workstation, I used a program called TRS Tools. It's a Windows tool that'll open up DSK files and essentially let you drag and drop files, you know, between a folder on the machine and the DSK image. The registered version of the M4 emulator also comes with some command line tools for DOS that'll let you extract files as well. But I found that path a little bit easier. So, got my little floppy here with the 3 images on it. I'm going to go ahead and get it in drive A. We will CD into the M4 registered folder. Of course, we've got all the files here. We'll take a look at the A floppy. And there's the 3 files. I'm going to copy all 3 of those over here. And like I say, they're all exactly the same size. I suspect they're all identical. I didn't WinDiff these to see if they were the same, but you know, said what the heck. I'm going to install DOS key here. It should be in my AutoExec bat. If you're unfamiliar with DOS key, it lets you recall previous commands, that kind of stuff at the command line. I'm going to copy 1-modela.iii to model 4. Oops. Well, didn't mean to do that, but I can rename the model 4 file. Rename model 4 to model. Oh boy, it's hard to type around the camera. At least that's what I keep telling you. Model4.rom. I should now have a model4.rom file. Per the instructions for M4 installation, you basically go through what you just saw, and now when I try to start the machine in Model 3 mode, it will find the Model 3 ROM stuff in that image. At least that's how I understand it works. So let's start the emulator. Of course, it's registered to me. And I'm guessing at the moment that ROM image probably isn't the right ROM image, and that's why this is hung up. That kind of sucks. The emulator is running. Oh no, I know what I've done. I need to hit F8 and actually map some images. So I'm going to map the M4 diag. I can hit Tab, and I can come over to M4 diag and mount it. For drive 1, I'm going to go ahead and use the B physical floppy, and I'm going to restart the machine. And it didn't restart. It didn't fail, as it did before, not finding the ROM image, but it didn't restart, so there's a chance that is the wrong ROM image. Let's exit the emulator. And off the off chance these are packed differently, I'm going to copy 2-modela.iii to model4.rom, overwriting it, and restart the emulator. Oops. Make sure I've still got what I thought mounted, and I do. Go ahead and restart, and the same issue. Oh, there it is. So that second ROM actually worked. So apparently those 3 images were slightly different. There was some notes on the website I found these on about packing and that kind of stuff for the ROM image. Anyhow, this is a Model 3 disc with the Model 4 diagnostics on it. I've been looking for this because I want to test the upper 64K RAM we installed in the previous video. So now I'm going to go ahead and reset the machine to, I'm going to take for drive 0, and I'm going to take the image I know is bootable with backup on it. In drive position 2, I'm going to mount the M4 diag. And I'm going to restart the machine now, and that should start it off of, yep, 11.11.84. And I believe now if I do a dir:2, it'll actually say invalid drive number. I've actually got to run a command here to enable drive 2, and at the moment I don't remember what it is. Let me find it in this instructions here. It should probably be put into the startup for TRS-DOS. I'm still scanning. There's all keys, snapshot menu, virtual disk menu, which you've seen me in and out of several times here. There it is. So the command, oh, sorry about bumping the camera, is system. Drive equals 2 enable. And now the beauty of, well, DOS key isn't going to help me here. So, sorry about that. Drive equals 3 enable. And I should now be able to see that DSK file we mounted as drive 2, and it says there's no disk in 2. That's interesting. And of course that's a bad command. There's no disk in. That was interesting. F8, so drive 3 looks like it just defaulted to the B drive. Not that that's important. Now I don't know if I can actually create a backup or not. Backup. Actually, let me Control C out of this. I don't remember which key is break. We're going to take from drive 2. We're going to write the image to drive 1. And it's not finding an image on the M4, which is okay. I'm sitting here trying to remember, did I actually find a way, a different way to image that floppy? I'm looking through the set of floppies I've actually created here in the emulator, and no, I didn't. So, well, that's a shame. Let's go back to drive 0, and let's go ahead and pick up the other M4 diagnostic image I found. And let's restart the machine on that image. Modified by software pirate. So this must be a an unprotected image. Quit and return to TRS-DOS. Backup from drive 0 to drive 1. Oops. And move the system along with it. Oh, I don't have a floppy in. Oh, interesting. It is. I don't remember which key is the break key. Again, I got to spend more time in the emulator and getting used to things. Keyboard. Let's see. Which key is mapped to the break key? F10 and escape. So he's trapped. Control delete, it's not getting through to DOS. So this is actually writing to a drive without a floppy actually mounted in it, which is understandable. Alt home, backspace, and well, I'm going to do something cruel here, and I'm just going to cycle the power to get back control. That probably wasn't the best idea. I do have the DSK images backed up on my other machine in case I corrupt one of them. And I've run into this a couple of times, and this is just how sloppy I have these cards mounted and cabling, and I do need to find a case, and that's no better. Sometimes it'll clear out of this on its own. There it is. So the floppy is mounted in drive B. Hopefully all this is on camera. I'm just double checking that it is. I'm going to immediately install DOS key just because it's very useful. Oops. CD M4 registered. Let's go ahead and run M4 again. F8. So because I didn't exit cleanly, it didn't save the mappings from before. So we're going to take the Software Pirates version and mount it, and we're going to reboot. And 11/11/84, just my default date. Quit. I'm going to go ahead and format drive 1. I have to think about it for a second here. And that'll format that floppy. And there it is, accessing it. Use disk. Yes. And I'll just go ahead and let this format, and we'll come back when it's done. So as you can see on the screen, the formatting got hung up. I'm not sure why. I'm not sure it's critical. I'm going to restart again. And quit. I'm going to go ahead and try to back up to the floppy we just attempted to format. It got all the way through and then hung writing the system out. I'm not sure why. I think we'll still be okay. It saw that there was something on it. Sorry about bumping the camera. I'm going to say no to the reformat, and we'll see what we get. So it's reading the DSK image. It's now writing to the floppy. What we can do here once the floppy has been backed up to and completed is we can then mount it as drive 0 and boot the machine and see if we can actually boot from the floppy. Which will tell us we have a bootable floppy. I'm pretty excited to be getting a diagnostic disk together. Because like I said, I really want to test the 120 or the extra 64K in RAM we added to the Model 4. And of course I've got some other images that were created the same way that I believe have the high-res software for the high-res card I have for the Model 4 that we'll be doing a video on in the near future. So M4 Diag Software Pirates, creating a label here for it. And rather than bore you with this entire process, I'll stop the camera and we'll come back when it's hopefully done. Actually, while this is doing its thing in the background, let's go ahead and talk about 360K drives. So this is a 360K drive that was salvaged out of a very dead, I think it was an XT class machine, I'm not sure. It was a very dead portable that I finally gave up on and salvaged. It's a pretty standard half-height 360K drive. It's got this push button mechanism that I'm not particularly fond of. I need to lubricate the moving pieces in it. It sticks. I will get to that. I'm trying to hold it in frame here. Hopefully we've got focus. With the 1.2 meg 5¼ inch floppy, the one we're currently using, those come from the factory. pre-jumpered to be drive select 1, and that way the twist and the floppy interface cable selects which drive it is. If you're after the twist, you're drive 0. If you're before the twist, you're drive 1. In the case of this drive, it's got a little jumper block here, and it's probably really hard to see. And then up the side of it, it's got numbers 0, 1, 2. And there's a little jumper on here that I'm sure you can't see that I have moved to jumper this to be drive 1. There's also a couple other signals on here. This MX signal that I believe has to do with motor on and off. In this case, having that jumper off seems to make this drive work okay. I think on this drive the motor runs continuously, but that's okay for the purposes I have here. I have used on all these drives a 5 1/4 inch floppy cleaning disc. If you've never seen one of these, it's got a somewhat abrasive disc in it. It's slightly abrasive. You put a little alcohol on it, stick it in the drive, and often just trying to boot the machine will get the drive spinning, and you'll hear it go. You'll hear it make noise as it cleans the head. This is always a good idea with these older drives. A comment about these older floppies, we talked about these a bit earlier, is the oxide that is the disk surface on these older ones tends to come off, and it gums up the head, and the drive becomes highly unreliable. So, if the drive suddenly seems to start working, cleaning the heads can often bring it back. Sometimes you literally need to get in here in an open drive like this. I can't really fold the head up out of the way, but down in there's a little white ceramic block, and that is the bottom head, and there's one on the top. And sometimes you need to get in there with a Q-tip and some alcohol and scrub a little more aggressively to get that oxide off. You just got to be careful doing it. So, if you're lucky enough to find a drive like this to use for this, I kind of prefer it just because it keeps it old school. The same comment from earlier about the BIOS must be set correctly. The BIOS is set to 360K disk when using this one, and it's set to a 1.2 meg 5 1/4 inch drive when using the drive we currently have on the system. So we're getting close to finishing this up. I'll bring the camera down just so you can see the drive kind of complete here. Actually, it's off verifying it's on track 17. It didn't make as much progress as I thought. As you've seen with this and all my videos, I go through a lot of trials before I get things to work. Backup complete. So sweet. I'm going to go back into F8, and for drive 0, I'm going to mount that B floppy. Oh, I've got to unmap it from drive 1. And I'm going to hit R here to reboot the machine, hopefully from that floppy, and see if it actually is bootable. And it looks like it's not. Oh, it is. Very nice. So I have a Model 3. Well, I have the Model 4 Diagnostics. It's actually a Model 3 image disc. I'm not sure exactly the difference between a Model 3 image disc and a Model 4. There should be a drive and memory diagnostic menu. We'll go into D. Hopefully you can hear it accessing the floppy behind us. Floppy disk, disk alignment, 16K. Let's go ahead and run 2. And as I understand it, the Model 4 emulator registered actually will appear to have 128K. In this case, I don't have a speaker on this 46 motherboard, so we can't hear the sound test. And there it is. Obviously I need to tweak the sizing on my LCD, if I can remember what buttons are which. Auto. And that brought everything onto the screen. It recognizes there's a 128 K machine here in emulation. I may have to look for a manual for this because I'm not really sure how to interpret it, but this is really exciting. but I've actually made this amount of progress. So I'm going to go ahead and pull the floppy out and get it labeled and a Write Protect tab on it. It's labeled, covering the little notch, of course, on a 5¼ inch disc. Write protects it. So at this point, we've created a Model 4 diagnostic disc. I needed the registered version of this because it's a Model 3 apparently disc somehow. I've created a slot machine for the Model 4 disc that I think uses the high-res graphics card. Got a graphic basic disc. I've got TRS-DOS 602AN1. I have no clue what that is. The TRS-DOS 4 HR disc. And then I found on eBay, somebody in like Finland or Holland was selling a set of bootable discs. They were a little bit spendy. There's multi-DOS. They were a little bit spendy, a lot more than I wanted to spend, but it got me the CPM disc, and I wanted to play with CPM as well, and a new DOS 80 disc. Back when I was a serious Model 1 user, I actually had an LNW80. I used new DOS 80 as my primary OS. Anyhow, those are ancillary to this. We've got a set of discs we've created using the process I've kind of gone through here, and the next thing will be to get the Model 4 set up and boot these and play. Anyhow, we'll talk soon, and bye. So it's now going ahead and reading from the DSK image and writing to that physical floppy. I do remember I formatted yesterday, now that I see that 00 flawed tracks message there. So I did format from inside of the copy utility. Well, of the backup from the diagnostic disk. So just to kind of recap here, as we come to the end of this particular video, this is a 486 motherboard strapped for a 4080 or 486 DX33. It's got a Cyrex overclocked processor in it. That processor drops into a 486 DX33 socket, and by that I mean strapped for 33 megahertz, and then internally overclocks to 122, something like that, megahertz. There's 64 megs of RAM in the machine. You don't strictly need that much, that's just what I've got in it. And the machine is all ISA slots. Well, there's 3 of the, I think they're VLB slots here, but I'm not using them. It's a standard VGA card. As you've seen, we're just running in the 80 column by 25 line text mode, and all VGA cards will do that. I've got a rather old school floppy controller there. It's actually a combo card with serial ports, parallel port, joystick port, IDE, and floppy controller. I'm using this particular card because it does obviously support 360K floppies. I tried running this on a little bit newer rig, actually a lot newer rig. It was a Pentium 3, and the BIOS may not have been compatible enough. The on-board floppy controller on that Pentium 3 motherboard just did not itself do 360K. I tried getting this ISA floppy controller to work in the one ISA slot on that machine and just never had any luck. So this is kind of where I've ended up. So you could do this really with a 386 machine. I think would be more than adequate to do this as well. You know, and maybe like a pure Pentium or Pentium Pro might as well do this. It's just kind of, you know, what hardware supported is. Obviously, as PCs have evolved, there's less and less backwards compatibility. That's pretty normal. So once this gets wrapped up here, I'll be back. So the backup is completed to that floppy. I'm going to go back into the menu here and just attempt to boot from it. So I'm going to unmap the B floppy from drive 1. I'm going to map that B floppy, the TRS-DOS drive 0, excuse me, and I'm going to reboot, and it's accessing the floppy. As I recall, this took a second before to come up, and there it is. And we're there. So I will just go ahead and run that same memory utility we did before. There it goes. It's accessing the floppy. And we're going to go ahead and run 2. It's accessing the floppy again. So I do believe we've got a good shot of these floppies booting in my Model 4. In a future video, we'll go ahead and do that. And there it goes. And it does recognize as a 128K machine. So, very happy with this. I hope you found this video informative, and maybe it'll help guide you towards creating your own bootable floppies. We'll talk soon.